We'll continue with the previous derivation and we'll try to understand what is the value of magnification factor or magnifier in case of force damped vibration. So we have already derived the displacement in terms of its amplitude and direction or frequency. Now we have to substitute the value of z in this. So we are just continuing with our previous derivation. So value of z which we have already derived is nothing but k square root of 1 minus r square bracket square plus 2 zeta r bracket square sine omega t minus phi. Now it rearrange the terms. So x is equal to this f0 upon k term will write down in the numerator. So this is f0 by k, which as it is we have written, but we have written it in the numerator. Rest of the terms are as it is. Now this f0 upon k is known as the zero frequency deflection. So that is nothing but x0 and the denominator as it is. Now we know that stiffness is equal to force divided by deflection, force per unit deflection. So k will be equal to F upon f0 upon x0. So x0 will be equal to f0 upon k. So x0 we can transfer on this side, so k on this side. So it is f0 upon k is nothing but x0 that we have written over here. That is zero frequency deflection. Transfer this x0 on this side. So this is nothing but the initial deflection, and this is deflection at any time t. So this is amplitude divided by zero frequency amplitude. So this ratio is nothing but 1 upon square root of 1 minus r square square plus 2 zeta r bracket square sine omega t minus phi. Now maximum amplitude will occur when this particular term is equal to 1. So therefore we have modified this part in terms of x upon x0 as 1 upon square root of 1 minus r square square plus 2 zeta r bracket square. So this is the important part. So x is nothing but what? Dynamic amplitude, that is amplitude at any time t, and x0 is the zero frequency amplitude as we have seen earlier. So it is initial amplitude that we are taking into consideration. Now we'll define one term which is known as ohm or magnification factor or magnifier, and that is nothing but this left hand side part of the equation, that is x upon x0, that is dynamic amplitude divided by zero frequency amplitude. So the right hand side of the expression is nothing but 1 upon square root of 1 minus r square square plus 2 zeta r bracket square. So x upon x0 is magnification factor. Now we'll have some mathematical treatment over here. So we have to find out the maximum value of magnification factor, and to achieve that particular magnification factor for the given value of zeta, what we'll do, we'll differentiate this ohm with respect to b and equate it to 0. Now what is this particular b? B is nothing but we have assumed r square is equal to b. So d by dB of magnification factor is equal to 0. So this ohm is nothing but 1 upon square root of 1 minus r square bracket square plus 4 zeta square and r square. So we have squared this particular term. So 2 zeta r and bracket square is 4 zeta square r square. And now we'll substitute in place of r square, we'll substitute what? B. And then this is just the simplification part, correct? Instead of writing down r square, we are just writing down the term, that is b. So r is nothing but the frequency ratio and r square is the square of that particular term, which is a. So this is in place of r square, write down b. And now we have to differentiate this particular expression. So in place of r square, we have written b. So 1 minus b bracket square plus 4 zeta square. In place of r square, we have written b. So our variable is b, assuming the other terms as constant. So this is nothing but, now as the square root term is there, we can write down this as 1 minus b bracket square plus 4 zeta square b whole raised to 1 by 2, and this has to be equal to 0 to find out the maximum value of ohm or value of b. Now we'll convert this reciprocal into our regular term. So it is 4 zeta square b whole raised to minus 1 half. And now we'll differentiate. So this derivative part or differentiation part is important. So it is first we'll solve this as x raised to n part, that is n x raised to n minus 1, and instead of x we are having so many these terms are there, so again derivative of this term by chain rule. So n x raised to n minus 1, and again derivative of this term by chain rule. So derivative of this term we have to find out. So first we'll simplify over here. Minus 1 by 2 minus 1, that is minus 3 by 2. Now the important part. Derivative of 1 minus b square. Again here we'll have to differentiate x raised to, we have to use the formula of x raised to n as we have used over here. So it is 2 1 minus b raised to 2 minus 1, and again derivative of this term, derivative of 1 is 0 and derivative of b with respect to b is 1. So it is 2 1 minus b raised to 2 minus 1 n x raised to n minus 1, and again derivative of 1 minus b, derivative of 1 which is a constant is 0, derivative of b with respect to b is 1, plus 4 zeta square into 1, because derivative of b with respect to b is 1. So 2 multiplied by this minus 1, that will be minus 2. This minus 3 by 2 term we have written in the reciprocal part. So minus 2 1 minus b plus 4 zeta square has to be equal to 0. So this term we have cross multiply with 0. This minus 1 by 2, this 2, it is also cross multiply with 0. So only this particular term will remain, and that is equal to 0. That is minus 2 inside bracket 1 minus b plus 4 zeta square is equal to 0. Transfer this negative term on this side. So it is 2 1 minus b. This 2 will come in the denominator. So 4 by 2, that is 2. So it is 2 zeta square is equal to 1 minus b. We have to find out the value of b. So transfer this minus b term on other side. It will be b. And 2 zeta square on the other side. So it will become negative term. Now substitute the value of b. B is nothing but r square, and take square root on both the sides. So r will be equal to, we'll consider only the positive value. So r is equal to square root of 1 minus 2 zeta square. So when the frequency ratio is equal to this value, the value of ohm or magnifier has to be maximum. So formula for ohm is this particular one. Now in this particular formula, we'll substitute the value of r square, that is 1 minus 2 zeta square. So that we'll get the simplified form of this and maximum value of ohm also. So r square is 1 minus 2 zeta square. This 1 as it is, minus sign as it is. Again in place of r square, we can substitute 1 minus 2 zeta square in the under sign. So we'll simplify this now. So it is 1 minus 1. Minus minus will become plus 2 zeta square bracket square. So this plus 1 minus 1 we can easily cancel out. 4 zeta square into 1, that is 4 zeta square, minus 4 into 2, that is 8 zeta square multiplied by zeta square, that is zeta raised to 4. So this one we have calculated. So now we are left with 2 zeta square and square of that. So it is nothing but 4 zeta raised to 4 plus these two terms as it is. So 4 zeta raised to 4 minus 8 zeta raised to 4. So that will be minus 4 zeta raised to 4. And this 4 zeta square term is already dead. In the under root sign. Take 4 common, 4 zeta square common, so it is 1 minus zeta square that will remain in the under root sign. 4 zeta square, it will come out of this under root sign as 2 zeta and will left with 1 minus zeta square in the under root. So this is the value of magnification factor which is dependent on the value of zeta.